Hey crafters, this is Nilton from craftofprogramming.com. I am a senior electronic trading Java developer based in New York City. So you want to learn everything about Java monitors, wait, notify, and notify all. Cool, you are on the right place. Make sure you watch this video until the end so that you learn the whole thing about wait, notify, notify all. Let's get started. All right, so we're going to be talking about the producer and consumer, problem, which is a really useful way for you to learn about the wait, notify, and notify all Java object monitor methods. Okay, so if you are completely new to Java threads, say you don't know how to create a Java thread, you don't know how to use the basic synchronize keyword, please click on the link that I have below in the description, where I have a link to the playlist with all my videos about Java threads. So this video has a prerequisite on knowledge that you need to know. Please go watch those videos and then come back here. Let's go. Now the requirement, like I said, is we're going to have a producer and consumer, threads. Just one thread, one producer, and one consumer. But to make the requirement more interesting, the producer will basically be counting numbers like 1, 2, 3, 4, 5, and so on, right? And the requirement is that the consumer or the reader thread, right, should read this value, print it on standard output, right? But it should not read this value more than once, right? So you should not see repeated numbers on the console. And also the other requirement is that the consumer thread should not skip any numbers, right? So we don't want to see duplicate or triplicate numbers on the console, and we don't want to see gaps. All right, cool. So let's get started. To make this problem more interesting, why don't we do it interactively, right? So why don't we start by doing this? So let me get here a field, create here a field counter in our wait notify main class, okay? And let me create here a method that the consumer thread is going to call, called read, and a void method called increment that the producer thread is going to invoke, all right? So that's the two methods that we're going to create. And why don't I pause the video now and ask you to create two threads, one producer, one consumer, and the producer thread is going to call increment, and the consumer thread is going to call read. I'll pause the video now. I'm pretty sure you got it. Cool. So basically what we need to do is we need to create a thread here, okay? And this thread is going to be called the consumer, right? Let's have main started and join it. I didn't ask you to do that, but it's okay. I mean, the name we can call consumer, but let's just say C. And we want to do that. We don't want it to stop. We just don't want to do it once. So we need to have some sort of while loop. I have a while true. It's never going to stop. And what we need to do first is we need to create an instance of the wait notify main method. Okay, let's just call it notify main. Why? Because those two methods, read and increment, are instance methods of the class wait notify main. So we need a wait notify main object. Okay, that's what I have here. And then inside a while, right, what I want to do is call notify. It's a consumer thread, so it's going to call read, right? And what we want to do is we want to print this value to the console, okay? So what we need to do is let's get the value and let's put it, actually let's just put it here, okay? This is my value, and I just want to say that my consumer thread read the value, and that's my value. Okay, if I put it here, you see what I'm doing. All right. join here. Let's just have main return throw the exception. So that's what our consumer thread does. It's something very simple. It's looping because remember we want the value to be the thread to keep consuming the values that are produced by the producer. And you don't need to use system printf. You could have just done, you know, a print line would have been enough. But what we need to do is to call notify main, the instance of our object, and call read. Okay, so that's what the consumer thread does, right? And an interesting thing is the current thread. This gives a handle of the current thread, and we want to print the name of the thread. All right, and I'm just giving a name C here. Now for the producer thread, right? So something a little bit similar, right? So notify main, and what we want to do is we want to call increment. All right, and let's just change here the name to P. Okay, and let's call this producer. All right, so that we are consistent. Okay, producer, and all right, so let's just move this thing here. We create the consumer and the producer, and then we have main join both the consumer and the producer, right? So now we have our two lovely threads, a producer and a consumer, calling the right methods, right? So remember, the requirement is for the producer to increment the value and for the consumer to be writing those values sequentially, one by one, 1, 2, 3, 4, 5, 6, 7 on the console without skipping a number or without repeating the same number, all right? So why don't we go to the read and increment methods and do that, right? Okay, so let me give you a hint to see if you can do that. So we're going to be using wait and notify. Okay, just wait and notify. Don't worry about notifyAll. And what we want to do is on the read here, we want to check if the value has not been read. So let me give you another hint actually. Let's create here a boolean, which let's call it is available. All right, cool. Let me minimize main now. Okay, so now we have a counter and we have is available. Okay, try to use the flag is available. Okay, as a means for the reader to know, oh, the value is not available, so I need to wait, right? And use the is available flag on the increment method for the producer thread to know, oh, the value is available, meaning it has not yet been consumed by the consumer, so I need to wait. Okay, I'll pause the video and give you a chance to do that. Did you get it? Awesome. So you know, you could have done something like if the value is not available, right? Then we would like for the thread to wait, okay? And likewise, so wait actually throws an interrupted exception. Let's add it to the method. And likewise, on the increment here, it's actually the opposite, right? If the value is available, meaning has not been read by the consumer, we want the producer to wait. And let's add this to the method, okay? All right, cool. Now, there is a problem here. Actually, there are two problems. Let's talk about those problems in... why don't I run this for you to see what the problem is, okay? Because it's something very important that you need to be aware of. All right, so forgot here to... All right, so obviously, you know, the read method needs to return something. Let's return the counter, okay? And increment here, yeah, this guy throws an exception. So let's run within a try catch block, and so does increment here. All right. Okay. So now we have all the compilation errors fixed, and let's just minimize main here, and let's run this to see what we have at the moment. Uh-oh, we have a problem. We have a legal monitor state exception. Current thread is not the owner, and this is happening on line 39 here. What's going on? Why am I getting illegal monitor state exception? Okay, so you must always, right, own the monitor's log, right, before calling wait on that monitor, right? So wait is being called on the instance of wait notify main, so this instance, right? So the thread, right, before calling wait or notified needs to hold the lock, right? Then how do we guarantee that the thread would be holding the lock? I'll pause the video. Yes, of course. So we need to mark this method as synchronize, right? And also this method here, all right? So now both read and increment, which call wait, okay? And they will also call notify. Now they are holding the monitor's lock, right? Prior to calling wait and notify, okay? Let's run this. So now, as you see, we got rid of the exception. We don't have the exception anymore, okay? Now you ask, why does a thread needs to be the owner of that lock when it calls wait, okay? It's a little bit involved, but basically a monitor is a Java construct, right, that contains a log and a wait set, right? A wait set, as the name implies, is a set that waiting threads wait on, right? Because when you call wait, you're actually adding a thread to that wait set, right? You need to make sure that this operation, right, is done atomically, okay? So the thread needs to acquire the lock on the monitor, all right, and then make the change by adding the thread, right, adding itself onto the wait set, right, because that's a critical section, all right? The same thing on the notify. Notify is the opposite of wait. Notify is waking up one thread randomly, waiting on that wait set so that it can, compete to acquire the lock, right? So because there is this change of the wait set, it's a critical section. That operation needs to be done atomically. You need to be holding that lock, right? Good. So there is another bug here. The bug is that we are using if when we should be using while, okay? So why is that? It's something called spurious wake up, right? A thread may be woken up spuriously, right, from this wait, okay? And if you do not have this wait wrapped inside a loop, like say while, what's going to happen is that this value, the thread woke up before or with this condition not being true, i.e. in this case, the value not being available, because it's inside an if, the value is not going to be checked again. Same thing, same argument applies to the producer, right? So because of this spurious wake up, right, you need to make sure that the waits are always inside a loop, a while loop, okay? That's why we have this. If there is a spurious wake up, what's going to happen is the thread will check again the value of the flag. Oh, it's still not available. And it's going to wait until the flag is until this condition is actually true, all right? Okay, so now let's continue. So now we have a way to coordinate the value. So the thread checks, oh, the value is not available, now it waits, right? And on the increment side, the value is available, right? Meaning it has not been read by the consumer, it waits, okay? So what is the next step? Okay, so the next step is obviously the consumer is going to read the value, right? How does it tell the producer that the value has been read? Okay, it has to tell it by saying that the value now is not available anymore, okay? That's how it communicates that to the producer. And also, conversely here, after the producer writes the value, right, it needs to say, hey, now the value is available, okay? So that's how they coordinate this. And then, there is one other thing that we need to do here, okay, which is suppose that after the consumer tells the producer that the value is available, what happens if the producer is waiting, right? How will it know that now the value is available and it can write again? I'll pause the video. Yeah, you got it. So we need to call notify here, right, on the consumer thread, and the same thing here, right? We need to call notify. All right. Now, why notify and not notifyAll? Okay, so this is a big topic, that I have created a video. I'll put a link here on a card and also in the description below. Please go watch that video on why you should use, when should you use notifyAll versus notify, and then, if you're interested in knowing about that. Okay, then I think this pretty much solves our problem, right? The consumer checks the flag. If the value is not available, it waits, right? Then it gets notified by the producer that the value is has been read. It wakes up, and then it acquires the lock, right? And then it says, oh, okay, I have read the value, right? Then it's going to notify the producer that may be waiting to produce the next value, and it returns the value, right? On the producer side, it's the opposite story. Oh, the value is available. It has not been consumed. I'm going to wait. After it's notified by the consumer that the value has been read, it's now going to produce the new value. So let's do that. So let's just say wrote value. Okay. And this is where we increment the value, and now we have a new value to be consumed, right? Now, notice that this operation plus plus counter, right? It's actually what's called a compound operation, right? What does it mean to be a compound operation? It means that it's an operation that is actually split into multiple instructions, right? The value needs to be read first, so the current value, and then +1 is added to it, and then it's written back to the variable. Okay, so there are actually 3 operations. This is one of the reasons why this code needs to be inside the synchronized block. Okay, so the new value has been produced, and it marks the value as available and notifies the consumer thread. Okay, so maybe why don't we do something here? Before this guy waits, why don't we write something that says that the value has not been read yet? Okay, so before the producer is going to wait, we're going to see that on system out. And here, let's do something similar. The value is not available. Okay, is not available when the consumer is going to read. All right, cool. So let's go here back to main, and why don't we, yeah, okay, we already have our threads printing here. All right, so there is only one thing missing here, which is add some sleep here, so that we can see something meaningful on the console. Let me create this method inside the wait notify main. Let's create it. Okay, and let's sleep the thread, if I know how to type, and let's sleep the thread for, I don't know, let's say for 2 seconds, or up to 2 seconds maybe. It's a more interesting scenario. Okay, and obviously sleep here throws an exception. Let's just surround on a try catch block. Okay, now we have our wonderful sleep method here, and we have the consumer sleep before reading the next value, and the producer is going to do the same thing. Let's sleep randomly up to 2 seconds before producing the next value. Okay, let's run. Alright, so the program ran for a while. I just stopped it, and remember, the requirement was that the reader or the consumer consumes the values as they are produced by the producer, without gaps and without repetition, right? So you see that the C is the consumer, read the value 1, and then read value 2, 3, 4, and so on, right? And notice that there was some examples here, or some scenarios where the producer had to wait for the value to be consumed by the consumer, which read the value, right? So the producer wrote 2, but before the consumer read it, it tried to write 3, and because the consumer had not read it yet, the producer had to wait. The consumer read the value 2, and then finally notified the producer that it was waiting, which then woke up, grabbed the lock, wrote the next value, and then again he tried to write the next value that had not yet been read by the consumer, and the cycle repeated, and so on and so forth. Okay? So I think I'm going to stop now. I hope you found this video useful. If you did, then please give it a like. It helps with the YouTube algorithm. Also, consider subscribing to my channel. I publish videos here on a regular basis, and also hit that notification bell. So now you know how to use the object monitor wait, notify, and notifyAll methods. Why don't we talk about the reentrant locks, multiple conditions here. Ciao, ciao.